Welcome to this tutorial on creating a sleek API for performing redirects using Google Cloud Functions. In this video, we'll explore how to build a lightweight serverless API that can redirect users based on custom logic, all while keeping costs low. Imagine users accessing your application and being seamlessly redirected to another service or website. This magical redirection is powered by Python and Google Cloud Functions, allowing for flexible and customizable routing logic. We'll start by setting up a Cloud Function in Google Cloud. If you're new to this, don't worry, we'll walk through the process step by step. Begin by searching for Cloud Functions in your Google Cloud Console and click to create a new function. For those using a fresh project, you'll need to enable some APIs first. Give your Cloud Function a descriptive name and opt for the second generation environment, which is recommended for current and future use. We'll configure the function to allow unauthenticated invocations, essentially creating a public redirection API. Since our redirection process is quick and lightweight, we don't need to allocate many resources. Minimal memory and CPU settings will suffice, and the default timeout should be fine. You can use a different service account if desired, but for this demo, we'll stick with the default. If you plan to use a Google Cloud load balancer in front of your Cloud Function, which can provide benefits like caching and advanced routing, make sure to activate the setting that ensures your function is only accessible through the load balancer. Now let's move on to the coding portion. We'll use Python 3.11 for this example and set our entry point to redirect. The setup is surprisingly straightforward thanks to the Flask framework that comes pre-installed with Cloud Functions. We'll start by defining our redirects at the top of our code. For example, we might want to redirect /google to google.com or /softwaresim to a specific pricing page. These redirects will be stored in a simple Python dictionary. The main function, redirect function, takes the request path, removes the leading slash, and checks if it exists in our redirects dictionary. If found, it performs a redirect with a 302 status code, temporary redirect. If not found, it returns a 404 error. With this setup, adding new redirects is as simple as updating the redirects dictionary. For more complex scenarios, you could consider using an external key value store like Redis, but for many use cases, this simple approach works well. Now that we have our code ready, let's deploy our Cloud Function. Click the Deploy button and wait for the process to complete. Once deployed, we can test our new service. Let's test it out. If we try just /Google, we get a not found error. But if we add /Google after the full function URL, it works as expected, redirecting us to Google's homepage. We can also test the software sim redirect, which not only sends us to the correct site, but to a specific page within that site. For a more production-ready setup, you might want to put a Google Cloud Load Balancer in front of your Cloud function. This can provide benefits like caching, custom domains, and more advanced routing options. To do this, you go to the Load Balancing section in Google Cloud, create a new load balancer, and set up a backend service using a serverless network endpoint group. It's worth noting that Cloud Functions, Generation 2, are actually powered by Cloud Run behind the scenes, so when setting up your backend service, you'll find your function under the Cloud Run options. It's important to consider your region selection when deploying your Cloud function and other resources. To optimize performance, try to co-locate your resources in the same region where possible. This helps minimize latency and can improve the overall user experience. When setting up the load balancer, you'll create a global configuration and use a backend service with a serverless network endpoint group. You can choose whether to implement Cloud Armor policies for additional security depending on your needs. After creating the load balancer, you'll accept the default routing, which directs all traffic to your Cloud function endpoint. With the load balancer in place, you can then configure an IP address and set up custom host names for your redirection service. This setup provides a more professional and flexible approach, allowing you to use custom domains and take advantage of Google's global network for improved performance. One of the great advantages of using Cloud Functions for this redirection service is its serverless nature. You only pay for the compute time you actually use, making it a cost-effective solution, especially for services with variable or unpredictable traffic patterns. As you expand your redirection service, you might want to implement more complex logic. For example, you could base redirects on user location, time of day, or even user-specific parameters. The flexibility of Python allows you to easily incorporate such logic into your Cloud function. Remember that while we've hard-coded our redirects in this example, for a larger scale application, you might want to consider storing your redirect mappings in a database or a key-value store. This would allow you to update redirects without redeploying your Cloud function. Thank you for watching, and remember to like and subscribe for more cloud computing and development tutorials. Please enjoy responsibly.